Part B says find the nature of the turning point of the curve. The curve is y equals to 1 out of 3 x cubed minus 5 out of 2 x squared minus 6x. Find the nature of the turning points. Before we get the nature of the turning points, let us first get what the turning points are. So to get the turning points, we need to find the derivative of the curve, that is the gradient function. So dy dx becomes, if we differentiate at that x cubed, that gives us x squared, minus, if we differentiate 5 out of 2x squared, it gives us minus 5x, and then minus 6 if we differentiate 6x. So this is the gradient function of the curve. Now, for us to get the turning points, what do we know at the turning point? We know that at the turning point, dy dx is 0. In other words, the gradient of the curve at the turning point is 0. So at a turning point, at any turning point, dy dx is 0. This implies that we need to substitute, that is dy dx is 0, so we substitute for it here. Therefore 0 equals to x squared minus 5x minus 6. Clearly you can see that this is a quadratic equation. You can use any method that is quicker for you, either factorization, formula, completing squares, or plotting graphs. But for plotting, it will take you a lot of time, more than 20 minutes. So let us see if we can factorize this. The sum the product is negative 6 and the sum is negative 5. So let's look for two numbers. If we multiply, give us negative 6. If we add, they give us negative 5. Those are the factors. So that becomes negative 6 and 1. Negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. So we shall have 0 equals to x squared minus 6x plus x minus 6. When we factorize this side, 0 equals to, we will have x into x minus 6 plus 1. Anyway, 1 is common. Is a constant, plus 1 into x minus 6. That means 0 equals to x plus 1, x minus 6. So in this case, what are the values of x? Either x is x plus 1 equals to 0, where in this case x is negative 1, or x minus 6 is 0, for which in this case x is positive 6. So these are the two values of x. Let me prove from the calculator. Very first, equations degree of 2, 1, negative 5, negative 6, 6, and negative 1. Now, these are the values of x at the turning points. Okay, this means that there are two turning points. The first one is when x is negative 1, second one is when x is 6. Now, what are the corresponding values of y? So when x is negative 1, what is the corresponding value of y, so that we can get the coordinate point? So substitute for x here. Our y become equal to 1 out of 3, x now is negative 1 cube, minus 5 out of 2, negative 1 squared, minus 6 times negative 1. This means that which now becomes positive 6. Please find a way of solving this. I will have negative 1 out of 3 minus 5 divided by 2 plus 6. I'm getting 19 out of 6. 19 out of 6. Let me press again. We'll have 6 minus 5 divided by 2 minus 1 divided by 3. Yes. So in this case, after getting the value of y, now the point becomes negative 1, 19 out of 6. This is one turning point. The other turning point is when x is 6. So for x is 6, we substitute in the equation of the curve here. I'll have 1 out of 3, 6 raised to the power 3, minus 5 out of 2, x is 6 squared, minus 6 times 6. Then you operate that. So from here, 6 raised to the power 3 divided by 3, minus 36, minus 5 times 6 squared divided by 2. I'm getting negative 54. Let me confirm that again. 6 times 6, 36 is negative. So plus 5 times 6 squared divided by 2. Then I say 6 power 3 divided by 3 minus answer. Yes, I'm getting negative 54. Therefore now the second turning point is 6 and negative 54. Now these are the turning points. We have got the turning points. Now let us get the nature. Let us tell whether this point is a minimum, maximum, or a point of inflection, as well as the second point. And for us to tell, we need the second derivative. There's another method, but I'm not using that method. D squared y dx squared. That means we need to differentiate this function for the second time. That is, dy dx, I'm seeing, is x squared minus 5x minus 6. Now let us get the second derivative. E squared y dx squared here becomes 2x minus 5. Now I'm going to test for the first point here, which is point negative 1, 19 out of 6. And then I'll test for the other point, second point, 6 and negative 54. In both points, we shall use the second derivative. So from here now, we say this is x, this is y. We substitute for x here. So d squared y dx squared becomes 2 times x, which is negative 1 minus 5. This here gives us negative 7. Now you judge, is negative 7 more than 0? Is it equal to 0 or less than 0? Negative 7 is less than 0. And we say that if the second derivative is less than 0, it is maximum turning point. That is what we said. This means that the first point, negative 1, 19 out of 6, is a maximum turning point. How about now the second point? Now we don't expect the second point to be a maximum turning point. Okay? they cannot be maximum at the same time. 2 points cannot be the same on the same curve. Now, from here, we say this is x, this is y. We substitute d squared y. We use the same second derivative for us to test, equals to substitute for x. So that we have 2 times x is 6 minus 5. 12 of minus 5 is around 7. 7. After getting 7, then you ask yourself, is 7 more than 0 equals to 0 or less than 0? 7 is more than 0. And we say that if the second derivative is more than 0, then it is, if it is more than 0, it is a minimum turning point. Turning point. Therefore, that point is minimum turning point. Therefore, the point 6, negative 54 is a minimum turning point, or it is a point of minima. So this is the solution to part B, and this is the overall solution to example 3.